Started with number 6 in our chapter 9, unit 10 review. We're supposed to classify the triangles as right, acute, or obtuse using the Pythagorean theorem. The key thing you need to know here is that we've got three conditions when we do the Pythagorean theorem. A squared plus b squared equals c squared, and that's for a right triangle. So if that is true, we know we have a right triangle. But if you compare a squared plus b squared and it's greater than c squared, it's not going to be a right triangle. That would be an acute triangle. And then if a squared plus b squared is less than c squared, then it is an obtuse triangle. Okay, so those are the three conditions. Let's just apply those now to each triangle. And so this is clearly, or at least it looks, like it's not a right triangle. We can't guarantee it's not right. We can check it though. To check it, we have to make sure that we compare a squared plus b squared to c squared. So the question becomes, which one's a, b, or c? Well, the only one that really matters is if c is the hypotenuse, it would have to be the longest side. So if this were a right triangle, it has to be the 6 for our c value. And that forces the other two to be a and b. Now, it doesn't matter which one you call a. It doesn't matter which one you call b. What matters is the c. So it's 5 squared plus 2 squared. The question is, how does that compare to c squared? So that's 25 plus 4, that's 29. 6 squared is 36. And so we can see that 29 is less than 36. And so this is an obtuse triangle. Okay, I'm just following this right here. A squared plus b squared was less than c squared. And that angle certainly does look obtuse. A right angle would be like this, and that is clearly more than 90 degrees. So it does kind of fit with the drawing. Let's do b here. There's got to be our hypotenuse, or side C. It's the longest leg or longest side. A squared, therefore, plus b squared. How is it compared to c squared? So 64 plus, I think that's 225. I think 17 squared is 289, but let's check that. Yeah, 289. And on the left-hand side, 225 plus 64 is 289. And so 289. So we can see they're equal. And therefore, this is a right triangle. That's using the top one there. Here we've just got the measures of the sides. And it's asking to decide if this is a right triangle, obtuse, acute. So again, we have to pick the longest side for the hypotenuse. Now in this case, two sides are exactly the same length, so let's just make one of them the hypotenuse. It doesn't matter which. And we aren't going to have to do all the math on this. You'll see why. Because right away we know it's greater than, because 24 squared and 24 squared are equal, so when you add this 49 to the left side is clearly going to be bigger than the right side. And therefore this is an acute triangle, just again going back to those equations and inequalities up here. Next one, 6, 8, and 10. Biggest side is 10, so that's going to have to be our hypotenuse. 6 squared plus 8 squared. How does it compare to 10 squared, which is 100? So 36 plus 64, looks like they add up to 100. So 100 equals 100. So this is going to be a right triangle. And I think, two more of those. All right, certainly a triangle. Remember how you check for a triangle. Make sure any two sides are always greater than the third. So 13 is greater than 7, and 12 is greater than 8, and 8 plus 7, 15 is greater than 5. So certainly a triangle. If it is, then a right triangle, then this would have to be the hypotenuse. And therefore, we just want to check if the two legs added together are they equal to, greater than, or less than the hypotenuse squared. So this is 25 plus 49. 14 carry 1, I think that's 74. The other side is 8 squared is 64. So it's less than, so this is obtuse. And our last one over here, they give us the triangle. This would have to be our hypotenuse if it is a right triangle. So it's a squared plus b squared. How do they compare to c squared? So 36 plus 144. I believe that gets me 180. And 14 squared is what, 196, I think? Yeah, 196. So it's less than, so this is going to be obtuse. And that takes care of those. 7, solve for the missing sides. Just to review this really quickly, let's throw in a piece of paper here. Turn it sideways. Just to review this real quick, we've got two triangles that we had to memorize. Well, the first one we memorized was the 45, 45, 90. It went x, x, and x root 2. And then we memorized the 30, 60, 90. Remember, the 30 is always across from the short side. The short side is x, so we go 1, 2, and 3, but it's root 3. So when we do this, we look at our triangle. We say, okay, 45, 45, 90 triangle. We compare it to our model now. Okay, the hypotenuse is the x root 2. The other two sides, it's an isosceles triangle. They're both 2 root 2. So x is 2 root 2. That's our two sides. And then our hypotenuse, if you notice, is x, which is 2 root 2. And then you're supposed to take it times root 2. That's 2 times root 4, so that's 2 times 2, or 4. So this side must be 4 units long. Let's look at our next one here. In this case, we got a 45, 45, 90 again. So these two sides are identical. Those are the two legs. So that's our x's. Just ignore their y's and x's. We're using our own here. And then 2 root x, that has to be this x root 2 side. So 2 root 6 has to be equal to x root 2. So to solve this, we're going to have to divide by root 2 to get the x alone. And on the right-hand side, the root 2's cancel, leaving x. And on this other side, this root 6 and root 2, they're both under square roots. We can simplify that. That's just 6 divided by 2, 3. It's root 3. So this is 2 root 3. And that, therefore, is how long each of your legs are. 2 root 3 is x, and the y is also 2 root 3. And the last one in this group, this is a 30, 60, 90. Okay, so remember, across from the 30, we just mark that as our x. So we're going to use our own labels and call this x. The hypotenuse is 2x, and the longer leg is x root 3. So we've got a little equation right here. Let's go ahead and figure out what x is. Divide by 2. X is 3 over 2, so that's this side, 3 over 2. And then whatever x is, you take it times root 3, and that is the longer leg. So we now know all three sides. There's everything, so you can